Hello and welcome. In this part, we're going to learn about how to take the derivative of the quotient of two functions. So if you have a function where it's a fraction and there's a function on the top and there's a function on the bottom, how can we take the derivative of situations like that? So there's a rule called the quotient rule that helps us do it. When we look over to our notes, we have that the quotient rule says the derivative of f of x divided by g of x. So here we're taking the derivative of this function that's a big fraction like this, where there's a function on the top, which we're calling f, and a function on the bottom, which we're calling g. And we're figuring out how to break this down into derivatives of simpler functions. So how to take a next step so that we can continue this derivative. And the quotient rule goes like this. You take g times the derivative of f minus f times the derivative of g all over g squared. So a shorthand version of it would be f over g prime, so the derivative of f over g, is equal to g f prime minus f times g prime over g squared. Now I know that seems a lot to memorize, and so to help you out a little bit, there's a mnemonic or a song that goes with this. So I'll sing it for you today. Now to get ready for this song, we're going to call f high, like as in the function that's high up there on the fraction, and we're going to call g low, so that's the low function. So f is high, g is low, and d is going to stand for derivative. All right, you ready? Low d high minus high d low over low squared. I need an audience button for clapping and booing probably too. All right, so with that out of the way, it's probably not the last time I'll sing it because I usually have it in my head every time I go through the quotient rule. We're going to try differentiating with example 10, y equals x squared minus 1 over x cubed plus 1. So here f is the top function and g is the bottom function. Okay, so dy dx, which again means the derivative of y with respect to x, by the quotient rule is going to be low d high minus high d low over low squared. There we go. So we've got x cubed plus 1, which is the low, times the derivative of x squared minus 1, which is the high, d high, and then minus high, which is x squared plus minus 1, times d low, which is x cubed plus 1, derivative of x cubed plus 1, all over low squared, so x cubed plus 1 squared. All right, so see how the quotient rule has now broken the derivative of this complicated function that we started out with into derivatives of its pieces, of the top, or the derivative of the bottom function, which are simpler to take the derivatives of. So let's go ahead and take the derivatives of those simpler functions. What's the derivative of x squared minus 1? If you said 2x, you're correct. The derivative of x cubed plus 1. If you said 3x squared, that's correct. Remember, the derivatives of those constants disappear. And the bottom, we're not taking the derivatives at all on the bottom. Okay, so then there's just a little bit of cleanup to do. And in this case, what we can do is distribute combined like terms. You just want to be a little careful about this negative symbol. Make sure that after you distribute the 3x squared, that you put parentheses around that so that the negative will distribute to each of the terms in the parentheses. So here we're going to have 2x to the fourth plus 2x minus, and I'll just put in parentheses 3x to the fourth minus 3x squared over x cubed plus 1 squared. So now we can distribute that negative right there, which flips the sign to each of the terms that it distributes to. And we've got 2x to the fourth plus 2x minus 3x to the fourth plus 3x squared over the bottom. And then we can combine like terms. And what I'll do is I'll just write the terms in order. So negative x to the fourth plus 3x squared plus 2x. That's what we have on the top. All over open paren 3x x cubed plus 1 close paren squared. All right, so there's a good simplified version of the derivative using the quotient rule. Okay, well, thanks for watching, and see you in the next part.